What's up, guys? You're watching Mazzei Formula. Appreciate you subscribing. Today we're going to talk about the fuel system on this car. I love sharing things with you guys. You know, going through this car, I've pretty much done everything twice. You know, the first time was the trial and the error, and the second time was getting it right. And so I think that learning can be the hardest part of a build, but it's also the most valuable part of a build. So any kind of setback that you have, it really sucks in the short run. You know, we've all been there when we're going to take the wrench and just throw it across the room. Tell everybody to get outside the room. I remember one time I had a bunch of friends over and they were all coming over and hanging out, and I was in a good mood chilling, and I'm underneath the car trying to do some wires, and I just finished like soldering all this stuff together, and I freaking like screwed up and wired it the wrong way. Man, I got so pissed. I was like, everybody get out of the room right now. I just cannot handle anyone in here. So everyone's been there before. We've all been stressed out. We've all had hard times working on our builds and trying to get stuff done. But it's those times right there where you learn the most, and the things that you learn, and if you get back up and try again from that trial and that error, those are the lessons you take with you the rest of your life, and the things that you can share and inspire other people with. So one of the things I learned, which I was hard-headed with, was the fuel system on this car. I first started out on this RX7 and I ran three Bosch 044 style pumps. They're actually the AEM 380s. Now they're pretty decent pumps, but the problem that I ran into was by running those three pumps, even though they were staged, I had a little surge tank in the back here. Even though those pumps were staged, it would still get pretty hot on the fuel returning back into that surge tank. So you got to think, you've got a 20-gallon tank of fuel, which actually stays relatively cool if that's all you're using. But the moment that you introduce a surge tank, and for those of you who don't know, a surge tank's like a little reservoir that sits in your trunk. You can put it wherever on the car, but basically it acts as like a reservoir that's always totally full and overfilling. You use the factory lift pump to fill the surge tank, and what that does is it keeps you from having fuel starvation. But the consequence that I learned on this car from using a surge tank was that it just couldn't keep up in traffic with the heat, because the fuel is always returning back to the tank. But on a surge setup, you're always returning it back to the surge tank first. And so when you have a small surge tank that has a small volume in it, it's problematic, because over time, that little tank gets really hot. And now when that fuel gets really hot and it's not under any pressure because it's on your return side, it begins to boil and cavitate, and you end up with vapor lock, which is where the inlets of your pumps cannot cool the fuel in effectively, because the fuel has now aerated and is sort of boiling, because it has a really low boiling point compared to, water or anything thick like that. So that was pretty problematic. And so I tried all different kinds of things. I tried a fuel pump speed controller from Aeromotive to slow down the pump at low demands, and that helped like tremendously. It helped a really good bit, but still, you would still cavitate that pump. And I'm not talking it's to the point where it's bad and your fuel pressure is dropping, but you can hear it whining. So I don't know if any of you guys ever ran a Bosch 044. They can be the greatest pumps in the world, but sometimes they can get really loud and they're just sitting back there screaming, right? So when the fuel gets hot is when those pumps scream, and then they start to pull more amps. So, I wrestled with it for a while. It did well. The car made almost 900 horsepower. The trick is to stage those pumps, but in today's world, there's things out there that are more reliable and simpler to use. So obviously we've got like the new Aeromotive brushless pumps that are out there. You've got the Fuel Lab pump that's speed controlled, so as we go forward in technology, simplicity is the main thing. You want to keep it as simple as possible. You don't want 3 relays powering fuel pumps and having to stage them with outputs from the ECU, because the more complexity that you have and the more advanced your system is, the more likely to have a problem, because you just have more possibilities, right? So what we ended up doing when we redid the back end of this car was we threw out all those pumps and we took the tank and we sumped it. I want to thank Danny Perez, because this was Danny Perez and Roan, these drag racer guys from up north. I'm real good friends with them, and they kept telling me, they're like, man, listen, stop with the surge tank crap. You need to sump the stock tank. You can use all 20 gallons of it, and you need to pull the fuel off the bottom of the tank. So that's what we did. We took this tank out, which is under the car, obviously. You can't really see it because of the diffuser in the way, but you can see right here is the sump. And this is like a little box that's welded on the bottom of the fuel tank at the lowest point. So now, instead of pulling the fuel in from the top of the tank, you know, where the hanger is up top, and pumping it into a surge tank, you're sucking it directly off the bottom of the tank. So no matter how low your tank gets, you still have gravity that's keeping fuel in that little square on the bottom of the tank, right? So now you don't need a surge tank, because this little thing right here is capturing the fuel and it's serving the purpose of a surge tank. It's almost like your entire gas tank has effectively become a fuel cell. Now, it's not quite as great as a fuel cell, but it's pretty damn good, you know. And now you can keep all 20 gallons, which is really important to us because this thing uses a lot of fuel, being that it's a rotary engine, and especially considering it's on E85, right? So then from there, we go to a mechanical fuel pump. Now, at the time when I chose to do this, most people were telling me that a mechanical fuel pump is probably not the best way to go because, you know, it's hard to set up. Sometimes it's a little more difficult to set up, but it has such a huge flow in return that you're going to have to run a massive return line back to the tank, which is going to require a massive regulator. So the cost is a little bit cost prohibitive when it comes to those two things, the line and the regulator. All of that has to be sized up. But a lot of people were worried about the drivability and the reliability on the street of using a mechanical pump, and most specifically starting the car, because a mechanical pump uses the crankshaft, the rotation of the crankshaft, and it runs off a belt, or you can drive it in a special way, which I'm going to show you. But like, you may see these on like high horsepower, some of the drift cars, but primarily drag cars that run methanol. You'll see these guys run them on, you know, like the RB26. They'll actually put them on the cam gear right off the front of the engine, or they'll put them off to the side on like a little pulley, you know, and it kind of just like an alternator, you drive it. So, you know, people don't like having something extra on the front of the motor, and they think, well, electronic is just very simple. But the greatest thing about the mechanical fuel pump is that you can run as much pressure as you want to, pretty much within reason, and it's not going to drop off and flow, and it's not going to suck down amps. So if the size of the gears in the mechanical pump can flow 6 gallons a minute of fuel, or 6 gallons an hour, or whatever, it doesn't really matter whether you run a base pressure of 50 psi or 100 psi. It's not going to fall off because you've increased your base pressure. The resistance doesn't slow down the flow rate so much on a mechanical pump as it does electronic. And that is extremely beneficial to a car like this that has a high RPM, low port velocity intake like the peripheral port, because we can run a higher base pressure without the penalty of flow loss. And that's going to essentially make the injectors atomize better, which gives us better fuel consumption, a better off-idle throttle response, and just an overall cleaner car. And we can get more horsepower out of the same size injectors by jacking up the flow rate through the higher base pressure, right? So this is pretty much one of the first RX7s that's on the street. I'm sure there's some other guys out there, but one that I've seen running around with a mechanical fuel pump on the street. And so, like I said, a lot of people are against them because of how you have to start the car. Since they're mechanical, you got to sit there on the key. So I've got a little trick for that too that I'll show you. But anyways, let's take a look at the mechanical setup. All right, so if we go over here, we're looking down the intake manifold. This is the charge pipe and the throttle body. This is our alternator, obviously. Right beneath the alternator, you can see the oil pump. And obviously it's an external mechanical oil pump that's belt driven off the crankshaft. Okay, now what's really cool about this is what NASCAR uses. I contacted a company that works with NASCAR, and they have an adapter plate that goes on the back of your oil pump. So check it out. If you can see down here, maybe you can see the adapter plate on the back of the oil pump. There's the front of the oil pump. We come behind the alternator, and you can just see the adapter plate, which is this little red plate on the back. It's kind of hard to see from the camera, so I'll put a picture up. But basically what happens is that adapter plate plugs into a cable, which is actually like a little drive shaft that's flexible. Think about like an old speedometer cable on an old car. And that flexible drive shaft runs all the way to the back of the car. And then what we do is we install this mechanical fuel pump made by Weldon, connects directly to the sump, And on the front side of this pump, on the other side of this pump, or the back side, mind me, is the cable. And so this cable drive, you can barely see it, plugs directly into the back of the pump. And when the engine's running, it's turning this mechanical fuel pump, and the mechanical fuel pump gears are inside this case. The gears are turning, and it's pushing fuel up this feed line, which runs all the way up to the motor. Oh, and by the way, there is a pre-filter. It's built into the fitting. So for people that have questions about that, comes all the way up to the engine, and feeds our fuel rails. First, it goes through this fuel filter here. We get it close to the injectors as possible, 6 microns. So any sort of dirt is collected right where it would be about to enter the injectors. I like to keep the fuel filter as close to the rails as possible for that reason. Minimize dirt getting to the injectors. And then we return through this massive Weldon regulator with a 10A line. And then to keep that fuel heat down as much as possible, we come back here and we have a massive oil cooler that we're using as a fuel cooler in the rear bumper. So the return line flows through this oil cooler before it goes back into the factory tank at the top. So that right there allows us to run the factory tank without having to have a fuel cell. You can see the return line right there. Without having to have a fuel cell, and effectively allows us to run a mechanical pump on the street. And it's very tucked, it's out of the way. And I'll tell you what, this car is running a factory alternator. Now I've got it modified for a higher voltage output, which I can do in another video. But we're able to get away with an 85 amp factory alternator. Why? Because we're tossing 3 fuel pumps that require electricity in turn for a mechanical system that is very unlikely to fail. So now I'll show you how we start the car and the way around that. Trying to start a car that has a mechanically driven fuel pump system, you'll see these guys in the pits with the drag car spray methanol or lighter fluid or something in the engine to try to get it to kick over. Because again, the rotation of the crankshaft is what drives the fuel pressure. And if the engine's not started and it's not spinning that crank, then you don't have enough fuel pressure generated to get the engine to start. And especially on the older ECUs, when you can't compensate for low fuel pressure by increasing injector duty cycle momentarily, it's going to be really hard to get an engine started. So just to make it really simple, so we never have to worry, we keep the factory fuel pump in the tank. So it's inside the tank hat in the back here, and it's literally just a Walbro 255. And that Walbro 255 tees in line into this fuel pump setup, okay? And we use that momentarily to start the car. So we come in here just like this, and I'll show you how it works. So this car's been sitting, it's completely cold. Sometimes you have to kick it over twice just to get the fuel down the runners. But we come over here, we flip on the battery, and this is the factory pump, the 255 that's in the tank. And this is our primer pump. So I'm gonna flip this guy on, and you'll see the fuel pressure will pop up on the screen. There's our fuel pressure 0. I'm gonna flip it on, and we have our prime pressure at a 57 PSI base. Now, I'm gonna turn the car on. Once it's running, I can flip the electronics off, and we're literally running on mechanical power alone. So here we go. All right, so there you have it. NASCAR cable-driven mechanical fuel pump that's driven off the back of the external Peterson oil pump. and it's sump mounted on the 20-gallon factory tank. Works flawlessly on the street, keeps the fuel temperatures down, allows us to run a high base fuel pressure with no problems with amperage, and we can get away with a stock alternator. We look at the E85 flex fuel sensor that has an integrated temperature thermometer, and the fuel temps are significantly lower. They're always usually under 100 degrees Fahrenheit, and it's just my favorite modification on this car. And I'm excited to be able to do this again in the future, help people out with this setup in the future. So I hope you guys learned something today. I also want to thank a really special follower. He turned 6 years old today. His name is Luke Ness. He's from Atlanta, Georgia, and Cheyenne is good friends with him. So I know you watch the channel, so happy birthday to you. I hope you have a fun day, man. So anyways, appreciate you guys watching. Gonna get some more content out this weekend. We're gonna do some fun stuff. We're gonna have a 2-rotor, a 3-rotor, and the 4-rotor. We're gonna be cruising around town. We're gonna go to this big car show that's popping off in Birmingham. It's up and coming. It's called Birmingham Magic City Octane. I'm telling you, very shortly, it's gonna be bigger than the Caffeine and Octanes in Atlanta. I mean, this show is freaking big. It's really cool. So if anybody's watching this, you wanna come out and check out the car, I'd love to meet anyone, shake hands, talk about racing, whatever you want, man. Come on out. Birmingham Magic City Octane. So thanks a lot, guys. You have a great night. Appreciate it.